Okay, hello 8th grade. In this video, I'm going to be going over the LP20 notes, which is going to teach us how to solve a system of equations by graphing. So you should have already completed the first assignment for this learning period, which had you practicing graphing lines in slope-intercept form. So this week, what we are going to be doing is learning how to solve a system of equations. So what if you're given two different equations and you want to figure out what the solution of those are? Okay. In order to solve a system of equations by graphing, all that you're really doing is you're taking one line and graphing it, taking the other line and graphing it, and your answer is where do those lines intersect each other? Okay, so we're going to do this first one together. Notice we're going to write down what our steps are. Okay, so the first step is to make sure that your equations are written in slope-intercept form. Okay, so write equations in slope-intercept form. Then graph them. Okay. The second step here, after we have written our equations in slope-intercept form and graphed them, the second step is going to have us look for the intersection of the lines. Okay. That point where the lines intersect is our answer. Step 3, the very final step, is to check your work. Oops, let me make sure we spell that right. Check your work by substituting that point into your equations. Okay. So we're going to write them in slope-intercept form. We're going to graph them. We're going to find the intersection, and then we're going to check our work. Okay. So in this case, we have two equations, and this is very, very similar. In fact, these equations come from your LTA assignment, so the paper assignment for this week. So this is one of the problems on there. Our equation is already in slope-intercept form, so we're starting with an easy one. Now all we have to do is graph them. Same process as we were doing before. So y equals 5 over 4x minus 2. We're going to grab a point. We're going to graph this, start at -2, 0, -2 for our y-intercept, and then follow the slope. We're going to rise 5, 1, 2, 3, 4, 5, and run 4, 1, 2, 3, 4. Okay? Now, we've only got 2 points that are going to fit, but that's okay. 2 points is enough for us to be able to graph. I'm going to take my line. We're going to spin these little arrows around a little bit to make sure that my line hits both of my points. Okay. And you can extend your line a little bit, make sure it goes past the end of your point so it's a little bit easier to see. Okay, and we've graphed the first line. Now we're going to graph our second line. Y equals -1/4 x plus 4. Start at the intercept, +4, go up 1, 2, 3, 4. It's going to start right here for us, kind of on that arrow. And our slope is -1 over 4. So my rise in this case is a down 1, and then over 2, 3, 4. Okay, and we've got our 2 points. We can connect those dots. Move my little guy around, move this arrow, try to get it to stretch, make sure it covers everything, and we're done. So first step, we have slope-intercept form and we graphed our equations. The second step is to find the intersection of those lines. So we want to know what point is it where these two lines intersect. Okay, and in this case, this point is at where x is 1, 2, 3, 4, and y is up 1, 2, 3. So our solution is the point where x is 4 and y is 3. Okay. The very last step then is to check our work. So what we want to do is we want to take our original equation and we can just check it by plugging in the x and the y. So y3 equals 5 over 4 times my x of 4 minus 2. And the same thing with the second equation. 3 equals negative 1 over 4 times x, in this case is 4, plus 4. And now we're just going to solve it real fast to see if we get the same thing on both sides. So 5 divided by 4 times 4, well, that cancels. And we have 5 minus 2, which gives me 3. And 3 does in fact equal 3, so it works out on this equation. For the second equation, do the same thing. Negative 1 over 4 times 4. 4 times 4 cancels. I got negative 1 plus 4. And negative 1 plus 4 gives me a positive 3. 3 does in fact equal 3. Since both of these came out to be true, we know we did the right work, and that is in fact our solution. Okay, I'm going to go ahead and clear out my drawings on this page. I'm going to do one more of these with you. The remaining problems are for you to work through on your own. So we can see we've got steps written here for us. We have our equations. Now we actually have to solve these equations to have the right form though. So first step, make sure we have them in slope-intercept form. In your text box down here, you are going to be showing me how you did that, what it looks like at each step of the problem. So if I have 3x minus 2y and it equals 10, the first thing we want to make sure we do is that we know what slope-intercept form looks like. So my goal is to have the y by itself on the left. It equals my mx plus b. So we want to make sure it looks like this form at the end. So the first thing I need to get out of there is that 3x, because it's the furthest thing away from my y. And that is a positive. So if I minus 3x on both sides, that would leave negative 2y on the left side. And it's going to equal, we subtracted 3x, so we have negative 3x, and that positive 10 is still there. Okay? Now, something I like to do is to line up my equal sign so it keeps everything organized. You can see I kind of moved it over a little bit. Now that we've done that, we'll move to the line below it. Okay? Now we want to get that negative 2 away from the y. Now remember, that's a multiplication, so if we divide everything by negative 2, we would get y left by itself equals, we'll have negative 3 over negative 2. Negative and a negative cancel. We're left with 3 over 2 x. And then we have our 10 over negative 2. 10 divided by negative 2 is negative 5. We'll have a minus 5 right there. Okay, and I'm just going to line that up. Boom. Okay. Now we have our equation in slope-intercept form. Y equals 3 over 2x minus 5. Okay. We're going to do the same process with the equation below to be able to get y by itself. Now, in this case, our equation actually has y already all by itself and everything on the other side. So all I'm going to do is flip the equation around so it looks like what we are used to seeing it as. Okay, so in order to do that, we come into our text box, and I'm going to start with my y equals, and then I'm just going to put everything else in the same order on the opposite side. So y equals negative 3x plus 4. And just like I did before, I want to line up my equal signs just so it's easy to see what's going on. Now that we have our two equations set up in slope-intercept form, we can graph them. So y equals 3 over 2x minus 5. I'm going to start at negative 5, down 1, 2, 3, 4, 5. Boom. And my slope is up 3 over 2. Grab another point. We're going to go up 1, 2, 3 over 2. Drop it off. And why not? We can put another point down there. Up 1, 2, 3 over 2. Okay. And we're going to connect our points with a line. Drag that line over here. Line up your arrows with the points we have. Okay, make sure it all lines up neatly. You may have to adjust this a couple of times. Take your time, be as careful and neat as you can. And then do the same thing for the second equation. So y equals negative 3x plus 4. I start at my intercept of positive 4, go up 1, 2, 3, 4, boom. And then my slope is down 3, and over 1. And we can do it again, go down 1, 2, 3, over 1. And now we can connect our points. Okay, and we just adjust until it makes a neat and organized line for us. And we can see our two lines are intersecting at this point right here. So now we just need to figure out what point that is. So if I start at 0, 0, that is where x is 2 and y is down 1, 2. So that is at 2, negative 2, because our x is at positive 2 and our y is at negative 2. Last step, we're going to check our work. So I'm just going to go ahead and use the equations we solved for here. So checking it on the first one, I'm going to have negative 2 for my y equals 3 over 2 times 2 for my x and minus 5. Okay, plug it in. We can solve it. 3 divided by 2 times 2, that cancels. We get 3 minus 5. Oops. And 3 minus 5 is negative 2, which does in fact equal our negative 2. Okay, doing the same thing with the bottom equation, y equals, oops, not y equals, excuse me. We're going to plug in the numbers we just solved for. So, where's my pen? Negative 2 equals negative 3 times 2 plus 4. Okay, start solving. Negative 3 times positive 2 is going to give us negative 6. Negative 6 plus 4 gives me a negative 2. So negative 2 equals negative 2. Both of these turned out to be true equations. They worked out, which means we did it correctly. Okay? The remaining problem on the next page, let me clear my drawings. This problem is for you to work out independently, and then there are 2 additional practice problems on the back page for you. Once again, we will be doing this as our notes in class this week, but in case you are absent or you need a quick refresher, you're more than welcome to go over it one more time. All right, see you later, guys.